All right. Sorry, I'm in technical difficulties. All right, this is our last example on here. So this says a 100 kilogram box of dimensions 50 by 50 by 50 is in the back of a flatbed truck. The coefficients of friction between the box and the bed, it gives you the static and the kinetic. What's the maximum acceleration that the truck can have without the box slipping? Okay, so if it's saying that, the box is sitting in the back of the truck, obviously the truck is moving, but is the box moving on the bed of the truck? No, it's sitting on there, and it wants to know what the maximum acceleration that the truck can go without the box actually moving. Okay, so if you look at your next slide, it's got some images for you. Notice that the friction, the static friction, is going towards the right, because if the truck accelerates, then the box is going to slide off, right, to the left. So we're gonna do write some stuff that we need here. So we've got the mass of the box is 100 kilograms. It told us that the box itself was 50 centimeters by 50 centimeters by 50 centimeters. So you could find the volume. It told us that the static coefficient is 0.4. The kinetic coefficient is 0.2. And now, again, think of it as our X and our Y forces. So if you think about the sum of the forces in the X direction, well, you've got friction, right? You've got static friction. And it's equal to, you can equal it to, force is equal to mass times acceleration. And that's what we're actually going to try to solve for, right? We're going to try to solve for the acceleration to see how much we can have before that box would slip. So you can also figure our forces in the Y direction. So we've got our normal force minus our gravitational force is equal to our acceleration times mass in the Y direction. Now, what is our acceleration in the Y direction going to be? Well, it's going to be 0, because we are not going, we're talking about the box sliding to the X, on the flat bed of that truck. So this is equal to 0. All right, so now we need to plug in some stuff for our static friction. Well, our max static friction is equal to our coefficient times normal, which is mass times gravity. Okay, so if we plug those numbers in, then we have 0.4 times the mass, which is 100 kilograms, times 9.8 meters per second squared, which is equal to 392 newtons. That's our maximum static friction. Okay. Now we are actually finding the acceleration that it has to stay less than. Okay, so the maximum acceleration that it could go. So if we look at this equation, and I'm going to bring it up here. Okay, so we're going to solve for the acceleration. And we already solved for the static friction of 392 newtons divided by the mass that it gave us, which was 100 kilograms. Okay, which ends up giving you a maximum acceleration of 3.92 meters per second squared. So basically saying that the truck needs to stay less than that acceleration. Okay, that is it. That is all of chapter 6.